Dear students, today I am going to discuss the topics of fluid flow under fluid mechanics and machinery. At first, what is fluid flow? In my previous chapter, I have already discussed what is the definition of fluid. Fluid is a substance which continuously deforms under applying of shear stress. And flow, what is flow? Flow is defined as the quantity of fluid like gas, liquid, vapor or sublimate that passes a point per unit time. On the other hand, it may be defined as a simple equation, that is flow F equals to quantity, that is Q, upon time T. On the other hand, it also defines delta Q, that is the rate of change of quantity. Now, fluid flow is a part of fluid mechanics and deals with fluid dynamics. It involves the motion of a fluid subject to unbalanced forces. This motion continuously as long as unbalanced forces is applied. The unbalanced force is gravity and the flow continuous as long as the water is available. When a fluid flows through pipes and channels or around bodies such as aircraft and ships, the shapes of the boundaries, the externally applied forces and the fluid properties cause the velocities of the fluid particles to vary from point to point throughout the fluid flow field. A fluid motion may be specified by either tracing the motion of particles through the field of flow or examining the motion of all particles as they pass a fixed point in space. The objectives of this chapter in part 1 series: at first, different types of flow, equation of continuity and Bernoulli's equation, that is the energy equation. Now, I am going to discuss types of flow. At first, in this figure, steady flow and unsteady flow. What is steady flow and what is unsteady flow? Now I going to discuss. What is steady flow? Steady flow, the velocity of the fluid is constant at any point, is called as steady flow. That means the flow যেখানে একটা flow যেখানে velocityটা constant, that means একটা ফ্লোয়িং ফিল্ডে ভেলোসিটি যে কোনো পয়েন্টে কনস্ট্যান্ট থাকবে, দ্যাট ইজ দ্য স্টেডি ফ্লো। হোয়াট ইজ দ্য আনস্টেডি ফ্লো? অন দ্য আদার হ্যান্ড, যে কোনো পয়েন্টে ভেলোসিটিটা কিন্তু ডিফারেন্ট হবেই, বাট অ্যাকচুয়ালি ইন টু ডিফারেন্ট পয়েন্ট। With respect to one point to other point, the fluid velocity is different. That is the unsteady flow. Now, uniform flow. Uniform flow, what is the definition of uniform flow? একটা পাইপ অথবা চ্যানেলের যে কোনো সেকশানে, মানে কি অ্যাকচুয়ালি লিকুইড যখন ফ্লো করছে একটা পাইপ অথবা চ্যানেলের মধ্যে যে কোনো সেকশানে তার ভেলোসিটিটা কিন্তু সেম হবে। দ্যাট ইজ দ্য ইউনিফর্ম ফ্লো। অন দ্য আদার হ্যান্ড নন ইউনিফর্ম ফ্লো, ভেলোসিটিটা ডিফারেন্ট হবে at all sections of a pipe or channel. That is the non-uniform flow. Steady flow, a flow in which quantity of liquid flowing per second is constant, is called steady flow. That means একটা ফ্লুইডের কোয়ান্টিটি যখন পাইপের ভেতর দিয়ে পাস করছে প্রতি সেকেন্ডে সেটা কনস্ট্যান্ট হবে। A steady flow may be uniform or non-uniform. On the other hand, unsteady flow, a flow in which quantity of fluid or liquid flowing per second is non-constant, is called unsteady flow. Uniform flow and steady flow. Steady uniform flow. What is the condition of the steady uniform flow and what is the condition of the steady non-uniform flow? I am going to discuss. What is the condition of the steady uniform flow? Fluid or the flow do not change with position in the same in the stream or with point, with time. That means what is the definition? What is the meaning of this? That means if we consider an example, we will understand the conditions of the steady uniform flow. The flow of water in a pipe of constant diameter at constant velocity, that is the steady uniform flow. Steady non-uniform flow, what is the condition? Flow changes from point to point in the streamline or stream but do not change with time. If we give an example under steady non-uniform flow, flow in a tapering pipe with constant velocity, that means pipe is not a constant, that means pipe decreasing or increasing. The velocity, constant velocity at inlet velocity will change as you move along the length of the pipe towards the exit. So that is the different into the two positions, that is the inlet and the exit. Unsteady uniform flow. What is the definition of unsteady uniform flow and what is the definition of unsteady non-uniform flow? At a given instant in time, the conditions at every point are the same but will change with time. If we consider an example, a pipe of a constant diameter, that means throughout the sections of a pipe the diameter is constant, connected to a pump pumping at a constant rate which is then switched off. Unsteady non-uniform flow, what is the definition of unsteady non-uniform flow? At first, we consider an example of a unsteady non-uniform flow. That means waves in a channel. Every conditions of the flow may change from point to point and with time at every point. That means একটা ফ্লোর বা একটা প্রবাহের মধ্যে এভরি কন্ডিশনে একটা পয়েন্ট থেকে আর একটা পয়েন্টে টাইমের রেসপেক্টে চেঞ্জ হচ্ছে। দ্যাট ইজ দ্য ওয়েভস ইন আ চ্যানেল। নাও laminar and turbulent flow. What is the definition of laminar and turbulent flow? Laminar flow means all the particles proceed along smooth parallel paths. That means all particles and definite path, have a definite path. That means all path of the particles have a velocity only in the direction of flow. Now in turbulent flow, in the turbulent flow there is the flow irregular manner. That means when the particles moves from one point to another point in the flowing field, the particles moves in an irregular manner through the totally flow field. Each particle has superimposed on its mean velocity fluctuating velocity components both transverse to and in the direction of the net flow. And in this figure we can see the flow field of the turbulent flow and the last one, transitional flow. In the transitional flow is the flow in between laminar and the turbulent flow. It exists between laminar and turbulent flow. In this region, the flow is very unpredictable and often changeable back and forth between laminar and turbulent states. In laminar flow, normally in Reynolds number within 2000. On the other hand, turbulent flow Reynolds number is greater than 4000, and the transitional flow, the Reynolds number in between 2000 to 4000. In the modern experimentation has demonstrated that these types of flow may comprise short bursts of turbulence embedded in a laminar flow. In this figure, we can see the laminar flow and turbulent flow. In the laminar flow, there is a definite path and the fluid particles move in the same direction. On the other hand, in turbulent flow, the particles moves in irregular manner. That means the fluid particles moves randomly in any direction is called turbulent flow. Now, this is the two figure where we can see the relative motion of unsteady and steady flow. In the left side corner, on the above, a observer, with respect to this observer, the boat is moving in this arrow direction. Flow pattern moves along channel with boat, changes with time. On the other hand, in steady flow, with respect to observer, the flow changes in the arrow direction. That means fluid moving past both pattern stationary relative to both does not change with. Thank you students watching my video and waiting for my next video. Again, thank you.